In this video, we'll be talking about lesson 2.2, which is parts of a circle. This is on page 52 in the textbook. So first of all, a circle is the set of points that are a fixed distance from a single point, and this distance is always constant. The point that a circle surrounds is called the center, and the distance that each point is away from the center is called a radius. Any line that connects any 2 points on a circle is called a chord, and a chord that goes through the center of a circle is called a diameter. So here is an approximation of a circle. And then if you take the circle and cut it along 2 points, then you get this is what is formed is called a arc. And if you take a circle and you draw 2 lines from the center to a point on 2 points on the outside, and you form what is called a sector. And this angle between the 2 lines is called the central angle of the sector. Now we'll talk about finding the length of an arc and an area of a sector. So to do this, the first step is to find the central angle of the arc. You have to multiply the circumference of the circle by the central angle of the arc, and then divide that by 360. So like if you have the same 120-degree arc, then the length is equal to circumference times 120 over 360. So for example, if the central angle here is 120 degrees, then the area of the sector is equal to the area of the circle times 120 over 360. Next, we have to talk about finding the perimeter of a sector. So again, a sector is formed like this by taking a slice out of a circle. So the length of these two is the radius of the circle. So if you add them up, that gives 2r. And then to find this length, which is the missing part of the perimeter of the sector, it's simply the length of the arc. So this is, and if theta is the central angle, this is equal to c circumference times theta over 360, as we saw previously in the length of an arc. So that means that the circumference of a sector, the perimeter of a sector, is equal to 2r plus c times theta over 360. A radius of 21 centimeters. And you have a sector cut out of that circle with a central angle of 120 degrees. Find the length of the arc formed by this in the sector, the area of the sector, and the perimeter of the sector, assuming pi to be 22 over 7. So first we'll find the length of the arc. So this is circumference times 120 over 360, which is equal to 2 pi times 21 times 1 over 3. And the 3 and the 21 cancel to form 7, which gives 14 pi, which is approximately equal to 44 centimeters. And the next problem is finding the area of the sector. So that's equal to the area of the circle times 120 over 360. So this is pi times 21 squared times 120 over 360. And that is approximately 462 centimeters squared. Final problem is finding the perimeter of the sector, and that is equal to the arc length plus 2 times the radius. So that's equal to 44 plus 2 times 21 is equal to 44 plus 42, and that equals 86 centimeters. The next problem is as follows. You have a spinner with a radius of 7.5 centimeters, and it's divided into 6 equal sectors. The problem is to find the area of each of the sectors. Now, since each of the sectors have equal area, and they all add up to the area of the circle, the area of one sector is equal to the area of the circle divided by 6, since there are 6 sectors. So this is equal to pi times 7.5 times 7.5 divided by 6, which is approximately equal to 9.375 pi centimeters squared. The next problem is you have two tables. One is a full circle with a radius of 70 centimeters, and the other one is a quarter circle with a radius of 140 centimeters. The problem is to find which table has a greater area. So to do this, find the area of each of the tables. So for this table, it is pi times 70 squared, which is equal to approximately 1,400 or 15,400 centimeters squared. For this table, it is equal to pi times 140 squared, and then divide by 4 since it's a quarter circle. So divide by 4. And this is equal to 15,400 centimeters squared. And so they both have the same area. Final problem is you have four balls that are placed in this fashion, and you're trying to find the area in between them, which is shaded here. So to do this, you have to first find the area of this entire square, and then subtract the area of each of these sectors. So first is the area of the entire square. So each side of the square has length of 2r. So which means that area of the square is equal to 2r squared or 4r squared. Now the area of each of the sectors. So each of the sectors is a quarter circle, which means that the area of the sector is equal to the area of the circle divided by 4. And so this means that each of the sectors has area of pi r squared over 4. And it's combining each of the 4 sectors together, you can multiply by 4, and that gives pi r squared. Now, finally, since the diameter of each circle is equal to 7, the radius is equal to 3.5, which means that the area of the shaded region is 4 times 3.5 squared minus pi times 3.5 squared, which is equal to approximately 10.5 centimeters squared.